But before starting that, I want to give also some brief information about our center, the Center of Expertise in Big Geodata Science, which is something new. So basically, when you were at ITC, it didn't exist. So basically, it's a horizontal facility that supports all ITC departments for better use of big geodata technologies in all main activities, education, research, and capacity building. Our mission is to collect and develop and share operational know-how on big geodata technologies to solve large-scale geospatial problems. And we have also a vision, which is making ITC and University of Twente a globally renowned center of excellence in big geodata science, which is a little bit ambitious target, of course, but we believe that it is achievable because ITC, as you know, is well known for excellence in education and research activities in geoinformation and Earth observation science. So we want to extend this to cover big geodata science. So how we are formed? Basically, the center itself will not do everything. So we have a small core team. We have a user soundboard with members from each department, each scientific department of ITC. We also have a steering group to oversee the activities. We will be in good cooperation with all ITC staff, engineers, project officers, also existing labs and existing teams. We will also, of course, be in cooperation and also utilize the resources available at University of Twente. So big data is very much integrated into machine learning and artificial intelligence studies. And at University of Twente, we have centers working specific on those topics. So we will be also in cooperation with them. But of course, we will be also in contact with you as our alumni working on these topics with partner institutions, especially in Global South, and also the big data community. So this is our idea. And basically, the core team will not do everything, so we will just facilitate the work. There are some activities that we define. So the first one is the knowledge development. So big data landscape is changing and changing quickly. So there is a need to provide up-to-date information to students and also to staff. So for that purpose, we will provide training activities, courses, in order to also provide quick information. We initiated a big geodata newsletter, which you can also subscribe. So at the end of the presentation, I will provide the links for that. So if you subscribe, you can obtain monthly updates about the big geodata technology. We will also develop an infrastructure for that because, as you will see in the presentation, big geodata needs a strong infrastructure. So we are aiming to provide this also for research and education activities. We will support projects by providing consultancy, advice, and also support the implementation. And also we will monitor what is going on at the national level, at the international level. We have also a special task, which is development of a reference big geodata curriculum for professional and educational development purposes. So basically, these are the activities of the center. It is planned activities because we just started. And you can contact us through our website. We have a functional email box, which you can always contact. And we have also a Twitter account through which we share actually recent news, not only about ITC and our work, but also recent developments in the field. So if you follow us at Twitter, you can also get informed about that. And always you can write to me as well. So coming to big data. First, it could be nice to define what big data is because it is actually a little bit fuzzy. Basically, big data refers to large and complex data sets which are difficult to handle using traditional systems to analyze and extract information. Here the keyword is the traditional system, because the traditional system is something changing. So the systems that we had 10 years ago are not comparable to what we have right now. So the definition of big data was completely different 10 years ago, and it's completely different now. And probably in the future also it will change. Big data is a very big domain. But an important part of this domain is, in fact, geospatial data, because the data coming from satellites is basically a big data. It was always a big data, and it is continuing to be a big data. But today we have also additional sources like drones, vehicles, photo cameras, or mobile phones, which provide information. We have social media, where there is information flowing in a very high speed. And most of the time, all this data has also a spatial component, so we know the location. Although sometimes we don't utilize this information, there is a big potential to use it for different purposes. Because geospatial data was something complex and difficult to deal with, historically there had been many computing methods developed to deal with the difficulties, to enable discovery, analysis, and visualization of data. So the geospatial field is not a foreigner to big data, in fact. But so far, the analysis was mainly on desktops. So basically, it was based on downloading the data to local computer and working on it by using your own workstation, which is usually limited and also time-consuming if you want to work with big data. Something is changing, and what is changing is, in fact, the development in the technology for hardware and software components, which helps us to deal with this big data and to deal with distributed data processing needs. So in the past, similar capacity was also available, but mainly available to specialized research institutes where they have the infrastructure and resources available. But nowadays, due to the developments, advancements in open source systems, software systems, and basically the cloud services, which are easily accessible, now from your home, basically you can access worldwide data, you can access infrastructure to process it, and basically you can do, for example, a nitrogen oxide distribution mapping at the global scale by using Sentinel data and by using Google Earth Engine, so without any cost involved. Such a study was not possible in the past, but now it is possible. So solutions exist, but in fact choosing the right solution is still difficult due to the nature of spatial data, the complex spatial data, and the challenging analysis needs, which needs an expertise and know-how. So what are the analysis needs? So let's have a look. The first one is basically you are happy with your desktop analysis with your workstation, but the work that you do takes a lot of time. So in that case, it is possible to make it faster by using parallel computing methods. So nowadays, almost all workstations, even the laptops, they have multiple cores. So that means although you use a single computer, you can actually use it as if it is multiple computers. And this speeds up the analysis needs for continental scale studies with medium-sized data. So that is possible. But for some more complex tasks, which needs a lot of computation power, which are complex in terms of computation needs, we need to use spatial computing units, which are nowadays the GPUs. With this kind of spatial units, it is possible to do machine and deep learning, which normally in the past was taking days, even weeks to complete, and now they are possible to finish in a couple of hours. So this is a very beneficial step if you want to work with this kind of analysis. And the last one is the distributed computing. So basically, if you have a very large volume of data, like at the terabyte scale or petabyte scale, a global high resolution imagery, or if you need to perform a very high complexity computations, which are beyond the capabilities of specialized computing units, then basically you need distributed computing. And in fact, this part is literally the big data part. So although the other technologies are also related. So not all analysis needs big data. One needs to carefully judge at the beginning whether the problem at hand needs big data approach. Here I should also highlight that basically nowadays big data analysis in fact includes all these first two components, because although we use multiple machines, a cluster of machines, each machine, because it has multiple cores, basically the computation is parallel anyway. And the modern big data infrastructures, they include GPU units to speed up the computations. So if we talk about big data infrastructure, usually those are also involved. So this technology overall is necessary to work with big data. Second item is the knowledge needs. So basically we need an analysis. We need to do the analysis, and in order to do the analysis, we need, of course, know-how and information to how to do that. And basically, there are some stages for it. The first one is, of course, try to use the existing methods efficiently, and to avoid actually distributed computing, big data computing, if possible. It is sometimes very easy to think that the problem that you have is a big problem because it takes too much to compute, or it is your machine is not enough to do the computation. But quite frequently, the reason is that you are not using the right tools, or you don't use the proper approach for computation. Maybe you don't use proper sampling strategy, maybe you are not using indexing. So this kind of existing tools and methods should be first evaluated before going into more depth analysis requiring an infrastructure. The second stage is to use the parallel computing, so on a single machine, so multi-threading. This helps you to speed up the computations, as I mentioned. And afterwards, basically, you need to have a look at specialized computing units because they need a different kind of expertise. You need to use different tools, and basically it needs a lot of learning, which may take time. The last resort is out of core computing, so which means use of clusters. Because if you come to the clusters, basically they need to be connected through a network. Network is not reliable, so that means you may lose some data. In that case, the analysis needs to be resilient. So you need to follow all the workflow. If something unexpected happens, you need to be able to recover from this. And this is not complex from physical infrastructure point of view, but also from software point of view. So you need to use much more complex, and that means slow software solutions for that purpose. So it is not easy. And the cloud infrastructure is actually a second step because you may have an in-house computing cluster which composed of, let's say, 3-5 minutes of machines, which might be easy to manage. But for bigger computation problems, you need to use cloud computing resources. That means you need to get used to use them. You need to know how to set up this infrastructure in an easy way by using existing cloud service providers. And you need to know how to cost effectively manage, because eventually cloud services are not free. You need to pay, and you need to learn how to pay less. So this is also a kind of expertise that you need to know. And these are mainly for finding a solution. But finding a solution is not the last point. So sometimes you start to provide this solution as a continuous service. So if you are a national institution responsible from providing some model results or providing some maps which needs to be updated regularly, then basically your workflow needs to convert it into a production system. And the production system is something different from a research system, so which may need further optimization. So this is also a last layer of knowledge need. So you need to know how to optimize. So if we come to the infrastructure, so as I told you, actually the idea should be avoid distributed computing if you can. This is very important to make the life easier. And in that case, actually, using your own workstation is the best solution. And today, actually, we should accept a computer with at least 4 64-bit cores, 32 gigabyte of memory, and around 1 terabyte of fast hard drive is the minimum standard configuration. So if the problem that you need to solve can be solved with such a resource, then you should think about upgrading if you don't have that resource. So because this is the easiest way. And it is also the most cost-effective way, because even nowadays the standard laptops comes with a similar configuration. What we need to know, in that case, we need to know how to use effectively the parallel computing tools and methods. So this is a prerequisite to benefit from the power that is available in this standard workstation configuration. If this is not enough, and if the task is required for a limited duration, so if you need to perform an analysis which will take a couple of days, then a very good option is to benefit from on-demand virtual machines available by the cloud providers. So currently, actually, it is possible to have 64 CPU and around 256 gigabytes of memory machine, a single machine, with less than €3 per hour. So for a couple of days computation, this is extremely cost effective because you don't have any investment, you don't have any maintenance cost, you only pay what you use. So it is quite effective. What you need to know is the familiarity with cloud computing, because in that case, the machine will be somewhere which you don't have direct access. So you need to change the way you work. And this needs a kind of experience. For long-lasting tasks, for regular big data use, there are two options. The first one is to use cloud services, and the second one is to have an in-house infrastructure. And my suggestion is definitely to try the cloud services first, because building an infrastructure is not easy. Maintaining an infrastructure is much more difficult. So, and these service providers, they are experts on this. They excel on this. They always follow the developments, and actually they follow the developments that we don't know. So they are really well ahead of a public information domain. And from that point of view, it can be nice to use those services provided if you have a budget for that. And the budget sometimes is not big, because it doesn't include investment maintenance. You only pay what you use. You can scale it very easily. So if you say, I need more resources, you can increase the resources very easily. And you can also access infrastructure, which is very difficult to obtain. So basically, having GPUs is very good for computation purposes, but the GPUs are quite expensive. So having them in your in-house system could be quite expensive. But they might be possible with cloud services. So the suggestion is the last result is in-house infrastructure for big data use, especially if you need low-cost solutions for a high number of users, because cloud services are usually expensive for that purpose. So what is necessary for using this kind of services is a transition in the modus operandi. So you need to change the way of work. Most of us, we get used to use desktop GIS applications, desktop remote sensing applications. We are quite familiar with it, but basically they don't work, or they don't work easily with cloud computing infrastructure. So basically you need to learn how to use these remote resources, which are rapidly changing. So this is a very critical problem of big data. It's a problem because the landscape is big. It's changing, it's rapidly changing, but at the same time it includes a lot of actors. So basically you need to know, or you need to have at least basic information about applications, about service providers, about data providers, the changing technology. So this is just a capture, a screenshot of the landscape, which was actually last year. Probably this year we have at least maybe one third more actors in the landscape. So it's really changing a lot. It is also partly complex, because basically when you need to deal with big data, then you need to use a stack of different applications and tools. So there is no single software package available that you can use directly. So they are all integrated. And the integration starts from the infrastructure level. So at the bottom in this figure, we have the infrastructure. So we have the storage, we have the CPU, GPU, and TPUs, and they are organized in a cluster way, which are connected through a network. So basically, normally, if you use desktop applications, which are not developed for cloud computing or for big data computing purposes, usually we have a file system which is in between our storage and infrastructure. On top of it, we have databases, some of which are geospatial databases, and on top of them we have our software tools like the GIS packages, remote sensing packages, etc. In case of big data, the situation is different. So basically, instead of file systems, now we have distributed file systems, which needs to be resilient, and they use a completely different technology. On top of it, because the tasks are distributed, because there are many resources to manage, we have distributed processing frameworks, which basically distribute the tasks and follow their processing and collect the results. So they are like orchestrating the tasks. The tasks themselves need to be, of course, described by using some special programming languages or by using some special frameworks. So on top of these processing frameworks, we have actually computing frameworks. And these computing frameworks are usually low level, so they provide the basic functions that you can use, but for our own purposes, for data analysis purposes, more specific for geospatial data analysis purposes, we need high-level frameworks on top of them. So in case of the standard data, we have Hive, Mahout, for example. In case of spatial data, we have Spatial, Hadoop, GeoSpark. So these are all specialized tools we need to use. There is also an intermediate level, which is the distributed databases. So basically the data needs to be stored in a way that can be accessed quickly. So we need actually databases, and the databases should be aware of distributed file systems. We need to be able to query data that is distributed among the cluster. So this is a partly different technology from available databases. And this part on the left-hand side is basically for basic analysis purposes. We have also machine learning, AI, which is a significant component of big data landscape. And for that, we have also a special stack because they are computing intensive. So basically, you need libraries, high-level libraries and low-level computation libraries, which helps with dealing high computation needs, linear algebra, matrix multiplication, the things that are needed basically for machine learning, high-level machine learning needs, which are provided basically with high-level frameworks. So we have machine learning frameworks like TensorFlow, PyTorch, which you can use to create neural networks to train them. This needs also a kind of low-level knowledge. So you need to know the functions, the methods for that purpose. And nowadays, actually, we have also a high-level machine learning frameworks, which are in fact working with available machine learning frameworks and helps you to build your workflow much more easily. And once the machine learning is done, once you obtain your neural network, for example, for classification or prediction purposes, and you need to deploy them. You need to run with the actual data to get some results. And in that case, it comes to the optimization problem that I mentioned. So basically, the machine learning tools needs to be optimized, and for that purpose, we have specific frameworks. So all of this is in fact data infrastructure, which we need to know. So it is quite complex. It is quite complex and it is evolving. But what is the current status? So let's see from geospatial point of view where we are right now with the available technology. So for that purpose, I will start with the already existing technology, which is basically the databases, more specifically the geospatial capabilities of the databases. So if we look at the normal non-distributed relational databases, we see that geospatial features and geospatial computing is very well supported. So if you look at Oracle database, for example, it is possible to use a four-dimensional geospatial data, 3D plus M, the time component. Complex features like teens, point clouds are supported. And basically, you can use spatial referencing systems. You can use the database to do the conversion for you. You can use the database for indexing purposes, for linear referencing purposes, etc. So all these functions are part of the database. So that means the analysis can be done by the database in a co-located way. So you don't need to use additional software. And because the computation is done by the database, it is quick because it has direct access to data. And this is also similar with other available systems. For example, PostgreSQL is a very common open source database. It has a PostGIS component and it features almost identical capabilities. And MySQL, which is also a quite frequently used database, even that one has a good support for spatial data. But if we come to distributed databases, which you can use right now, this situation is a little bit different. So first of all, the ones that are good in supporting geospatial data, they only support two-dimensional geometry. And usually it's spherical. So that means you cannot use reference systems. The operations that you can use are also limited. So usually only the basic operations like finding the nearest points or whether a point is inside the polygon or not are supported. But you cannot analyze raster imagery. You cannot do a graph computation, and it is also not possible to use advanced operators. And basically, for some databases which are very frequently used for big data, there is no support at all. So this is the situation. So basically, if you want to use big data, then you should be aware of these limitations. So big data is getting ready for spatial data, but it is not ready right now. So in terms of distributed computing frameworks, so okay, we have our databases, we can access the data, but the data needs to be processed and needs to be processed in a distributed way. So basically, we have two actors in the field for that purpose. The first one is Hadoop, Apache Hadoop, and the second one is Apache Spark. So Hadoop was basically initiated from a technology coming from Google. So it is an implementation of MapReduce technology. But Hadoop was using files for that purpose. So at each computation step, the output was written to disk and was loaded again. So, and from that point of view, although it was able to deal with big data problems, it was slow. So nowadays, it's not very much in use. We are using some technologies related to it, like Hadoop file system, but the rest is not operational, basically not very much operational for the time being. So the actual actor in the field is Apache Spark. So Spark is also working similar to Hadoop, but instead of writing the data into disk, it keeps everything in memory. And because it keeps everything in memory, it is quite fast. And there are some geospatial frameworks which are developed on top of Spark for computation purposes. And I have listed actually some of them. And basically, you can also use the links later on to get more information. What I want to highlight is how updated they are. So, as I told you, the technology is evolving very fast. But if we look at the available frameworks, we see that most of them are not updated anymore. So some of them stuck in 2017 and didn't get any kind of update. And that means that they are old, they don't follow the recent technologies. And that shows also the support is limited. So because in the big data, usually the tools, the software products that are available, they are open source products. They are supported by the communities, not directly by the companies. And the user support comes from the community. So if the community is not active anymore, so that means you may also face difficulties while using the systems. So it is very important to use tools with active community. And for the time being, we don't have much options available. And one option, for example, is GeoSpark. So, we have some options, that is good, but how performant are these options? So let's have a look. So this is some graphs and results from a comparatively recent study from 2018. So the aim of the study is to compare a traditional database, a PostGIS, with available distributed geospatial computing frameworks in case of Magellan and GeoSpark. So there are different data sets which are listed, a polygon, point, and line data sets. The first two or first three are in fact small data sets. So if you can see, they are small in size, around 10 megabytes, and the number of features are quite low. But the last two we can consider as big data, especially the last one, which includes 12 million points, and the size is 1.8 gigabytes. So this is not very easy to deal with. If we look at the performance, first of all, for queries, for attribute queries, we can see here in the first figure, the orange is also PostGIS. And the vertical scale is time. So PostGIS is comparatively quite slow when we use distributed computing systems. So there is definitely a performance benefit to use GeoSpark or Magellan. It is very clear. I need to highlight also the time, which is in seconds, and the duration is between 2 to 4, so which may not be quite significant. If we come to actual spatial queries, intersection of line and polygons, and then basically, and the less time that is devoted is better. And in that case, for small data sets, traditional databases are quite performant, and they are better than the distributed ones. That is clear. What makes difference is the big data. So if we want to, for example, do a reference system transformation by using the databases, and then using a traditional system takes almost an order of magnitude more than a distributed system. So in that case, for example, transformation of 12 million points by using GeoSpark takes around 100 seconds, whereas in case of PostGIS, it is a couple of thousand seconds. So the time change is quite significant. So overall idea is we need to look how big our data is, and for small or medium-sized data, using traditional methods may be a better approach than using the big data tools. But for very big data, it's clear that the existing frameworks provides an advantage. So this is the situation for low-level analysis. So using a database for geospatial computing is not easy. So you need to know SQL, you need to know the functions. So it is partly low-level task. But there are also some high-level systems available. And I have listed two of them, GeoMesa and GeoTredis, both of them coming from Location Tech. Location Tech is a working group under Eclipse Foundation. So basically, there are a non-commercial group of people or companies who provide spatial tools. They also include, for example, GDAL, Java topography suite, etc. So they are well-known actors in the field, geospatial field, not only geospatial big data field. But recently, they also provided these two tools. The first one, GeoMesa, is a suite of tools which are suitable to query vector data. So it can work with distributed databases. And if you have vector data, you can use GeoMesa for that purpose, to analyze the data, to visualize the data. If you need to work with raster data, then the alternative is GeoTredis. It is a distributed computing framework for big raster data. So it works with existing data solutions like Hadoop file system or existing databases. It can retrieve data from them, and it allows you to do the map algebra easily. If we come to more advanced topics like machine learning, there are also some solutions available. So I will start with the normal machine learning frameworks, and then I will move on to spatial ones. What is special for machine learning frameworks is actually the development, the evolution of the landscape and the changes. So basically, if we look at the timeline, around 10 years ago, in 2010, there was only one open source machine learning library available, which was Theon. In time, we saw further development, supported also big companies like Microsoft, Google, Amazon, and many frameworks are developed. So here on the right-hand side, you can see the situation in 2017, which can be considered quite recent, so only 3 years ago. We have many frameworks supported by the universities, by the research institutions, and also by big names like Facebook, Microsoft, Amazon, and Google. Just in 2 years, in 2019, almost half of these frameworks, they stopped development. They said they fulfilled their aims and they say there are better options available right now. So end of story. That means anybody actually who spent a lot of time to learn those frameworks, now they need to learn new ones, which is really a complication. So it is not easy. So basically choosing a framework is difficult. Learning the framework takes a lot of time, but eventually you can never be sure whether it will be supported in the future or not. So this is very critical. Before starting to learn something, please first have a look at the size of the community, have a look at who is supporting the framework, and decide accordingly. My suggestion for the time being, first of all, the Python for programming language. So basically it is the winner of the arena. So if you know Python, you can much more easily learn existing frameworks. And machine learning almost means you need to use GPUs, and for GPUs, NVIDIA is the leader. So it is dominating the landscape. It features a CUDA, which is a low-level programming library for computation purposes. And all the frameworks that you see here, they are based on CUDA technology. So basically now it is necessary to use NVIDIA products. I provided in the presentation a bit more detail about some of the tools that are available, including the links. So after the presentation, if you want, you can have a look in more detail. And my suggestion is to have a look to TensorFlow and PyTorch for machine learning purposes. So basically TensorFlow is supported by Google and PyTorch is mainly supported by Facebook. So they have big companies behind. And they have very good documentation. They have a lot of information for training purposes. They have an active community where you can ask questions. So this is really a benefit. But there is also a Keras available, and Keras is a high-level framework, which is much more easy to use. So this can be also an option. Just to demonstrate how easy to use, I want to show you a code. An actual code, basically, which creates a dense neural network with several layers. It compiles, so make it ready. It trains the neural network by using training data. It evaluates the performance, and then it predicts by using the actual data. So by only using around 10 lines of code, basically it is possible to create a state-of-the-art neural network, train it, evaluate the performance, and use it for production purposes. Of course, the task is not so easy, so you need to know a lot of more in-depth information, but this is to show how easy it became. So basically, you don't need to write hundreds of lines of codes for this purpose. So it is really easy. All this actually benefits from available infrastructure. It is distributed computing friendly. It uses the GPUs that are available automatically. So basically, it guarantees best performance from the available infrastructure, which is really very good. So basically, you can focus on the specifics of your problem instead of focusing the infrastructure and other needs. So if we come to the user interaction, so because the infrastructure is complex and because it is distributed, it is not very easy to interact with it. So it is not like sitting in front of your desktop computer and using QGIS, simply QGIS. So it doesn't work like this. But there are some options available. And there is also quite developments for this user interaction. And the first level of interaction, which is very frequently used by data scientists, is the interactive notebooks. So more famously, the Jupyter notebooks. So these notebooks allows you to connect to the infrastructure by using your web browser. You enter the code into notebooks, and the results of the codes are accessible also at the notebook. So whenever you do the computation, you can very easily visualize the computation. You can very easily get figures and create your workflow. So this is a very common way to access the infrastructure. For more complex tasks, usually the service providers provide a remote desktop connection, which you can use to connect to remote machines to run standard applications like you use on your own desktop. And for more advanced purposes, usually a shell access is also provided where you can have direct access to the infrastructure. More recently, there had been also some developments for data cubes, which are becoming more and more frequently deployed. What makes data cube special is data cube basically includes all the physical infrastructure needed for big data computing or all the computing resources. It includes the software tools, also the ones that I mentioned, like the interactive notebooks, etc. But in addition to those, they also provide data, ready-to-use data, which you can use for your own analysis purposes. And usually they provide support, they provide training, and they provide also case studies which you can use or which you can base your own studies on. There are some examples available. So Digital Earth Australia is a very good example. Recently, there is this Digital Earth Africa, and ITC is also a partner of Digital Earth Africa initiative for capacity development purposes, which basically provides data for the continental Africa. And there are also some examples from Europe, like Swiss Data Cube. And basically, the technology is open source, so it is possible to also take it and install to your own institution to use the technology. So it might be possible to create, for example, an Indonesian open data cube. So, as I mentioned, basically the cloud service providers are very important because they provide the easiest access to infrastructure, and they also provide some ready-to-use services and tools for that purpose. So I want to very briefly give some examples for three main service providers. The first one is Microsoft. So Microsoft is basically a special machine learning platform which provides a user interface, a drag and drop user interface, which you can see on the right-hand side. So you don't need to write code anymore. So you just create actually the connections and use building blocks for that purpose. But in addition to that, Microsoft also provides data science virtual machines, which are also optimized for geospatial analysis. So they include ArcGIS products, for example. And the Azure system provides distributed databases and also provides public data, mainly coming from Landsat and Sentinel services. So if you use Azure, you can also use those data for free. Second actor is Amazon, and in fact, Amazon is the biggest one right now in the domain. Amazon provides mainly two very well-known services. The first one is simple storage service to store data in the cloud, and the second one is elastic computing cloud service, which allows you to do computations on this data. Specific to geospatial computing needs, they also provide geospatial-friendly databases, and they have also a very big selection of open geospatial data, mainly coming from, again, Landsat and Sentinel services. But besides that, they have also data from OpenStreetMap, which you can use. They have also special services like SageMaker, which is a fully managed service for machine learning purposes, and which you can use to deploy and create your workflow entirely. Last actor is Google. So Google is also very well known with its infrastructure. So basically it provides a computing engine with special processing units, which are actually not available in other service providers. So these processing units are much more faster than the traditional GPU units. And basically, here I provided an example. So using a ResNet neural network for 90 epochs, we use a GPU, which is state-of-the-art, so the best available. It takes around 100 minutes. Whereas by using the Google TPUs, the same process can be completed in 8 minutes. So the performance gain is quite significant. And these units are available. And these units are also available for free. So if you use Colab of Google, which is a kind of interactive notebook, which allows you to write the code in Python, you can have access to these TPU units and you can benefit from this. So if you want to experiment actually with big data technology, with cloud computing, with GPU computing, I can also highly suggest you to have a look at this Colab, which is really good for training purposes. Google also has some specialized databases which are geospatial data aware. So they have BigQuery to query big data, and they have a special BigQuery GIS extension available to query geospatial data. And as I told you, they are also the main supporters of TensorFlow and Keras, which are the main machine learning frameworks. So from that point of view, Google is also an important actor. And actually, it is also a different actor compared to the others because there is also Google Earth Engine. So I don't want to go to the details of the Earth Engine because Hartanto gave a very nice talk about it some weeks ago. I just want to highlight how special Google Earth Engine is, because basically Google Earth Engine is like a data cube. So it combines the infrastructure, a computation library, and also the data sets under a single umbrella. So by using Google Earth Engine, basically you can access global high resolution data, you can access Google infrastructure, and you can also access a very well developed programming library, which you can use for analysis purposes. And on top of it, as a creme de creme, it is for free for research purposes. So I highly suggest you to have a look if you didn't. And Hartanto actually gave very nice examples also from Indonesia. So I believe it's really good to have a look. One thing that I want to highlight is also early involvement. So especially for those of you who are in the research institutes or in the national institutes which are responsible from Earth observation and GIS works for your country, for your region. So basically, being in good contact, being in collaboration with service providers also gives you the chance to involve early in the technological development. So here I want to show you an example from my previous institution, Joint Research Center of the European Commission. So basically JRC had an agreement with Google in 2013, so many years ago, when there was almost no interest actually on Google Earth. So this graph actually shows the members of Google Earth Engine. And as you can see, in 2013, there were almost no users. And compared to today, where we have hundreds of thousands of users. And at that time, to this early involvement, basically, JRC managed to create a global surface water dataset. And this dataset became a publication in Nature with more than 500 citations. So this study actually is something you can do right now by yourself. Because the data is there, the infrastructure is there, basically you can do it. Due to this early involvement, JRC had the chance to do it first. So from that point of view, I believe good contact with the service providers is very important, and it gives you a chance like this. And there are some mechanisms for that. Basically, the grants. All these service providers, they want to facilitate and they want to increase the use of their infrastructure, and they are heavily interested in Earth observation and geospatial tasks, and they provide some grants for that. So Microsoft has a AI for Good initiative, which includes several topics like accessibility, cultural heritage, humanitarian action, etc. But they have a specific grant for Earth observation, so AI for Earth. And basically, they provide grants for Earth observation focusing projects with a budget of $5,000 to $15,000. So this is a very good way to get in contact with them, because in addition to cloud credits, they also provide technical support. So you have the chance to work directly with them.
Excuse me, Dr. Girgin, I would like to remind that the presentation time will be like another 5 minutes. Thank you.
Okay, thank you. I'm finishing actually. Thank you. The second one is Amazon. So Amazon is also a big actor, and it provides funding. So the funding in that case can come up to $80,000, which is quite significant. And part of it actually also can be paid for supporting PhD studies or post-graduate studies. Basically, these grants, they have also a specific part that is dedicated to Earth observation. So there is a specific call for that. And the call is 4 times a year. It is easy to apply, so you need to fill in about 3 pages of documentation. You need to explain what you are aiming for. And they are also supporting especially localized studies, so or studies at the national level. So from that point of view, actually, it can be also a very good option. So if we summarize, basically, first of all, the big data technology is there. Big data technology is evolving, and basically, it is also providing support for geospatial data. But for the time being, we should be aware that the support is limited. So you may have some challenges in using this technology. Most of the cluster computing systems, they don't have native support for geospatial data. So that means even at the low level, you need to do a lot of work. There are some processing systems available for geospatial data, but they are mainly experimental. And due to their experimental nature, usually they have a small community, and their support is not long-lasting. We see that actually quite clearly with their deadlines. So basically, most of the systems finished further development a couple of years ago. Machine learning landscape, on the other hand, was quite heterogeneous a couple of years ago, but nowadays it is quite homogeneous, so we don't have many actors. And Python and CUDA are the clear winners. So if you want to start something, I highly suggest you to learn those technologies. The cloud services that are provided by the service providers like Amazon, Google, or Microsoft, they are quite similar to each other. So all of them provide almost identical virtual machines. They provide similar databases, etc. So they are not very different. So if you need to choose one, then you can really consider from user friendliness, the interface, and also the cost aspects. But here, I should highlight that Google Earth Engine is a game changer. So it is a completely different, unique system, which deserves to be considered. And early access and grants are very important. Not important because they allow you to do the work by providing some financial support, but they also facilitate visibility. So if you want to reach a wider community, if you want to have a higher visibility of your work, this is also a good way, because basically they also support this publicity of the existing work. So whenever you do something, it will be published by Google, it will be published by Amazon. It means it will reach a much more audience, which is very important. So these are the main topics that I want to highlight. So for any kind of questions or support needs, please feel free to contact our center. This is just to remind how to do that. Okay, thank you.
Thank you very much, Dr. Girgin, for your thorough presentation. Dr. Girgin has already presented about the spatial big data, about the tools and services to analyze spatial big data available for spatial data scientists. And at the end of his presentation, he mentioned that big data technology is evolving and support for geospatial data analysis that can be utilized by us, the geospatial scientists. Now I would like to open the discussion session. For the participants who would like to raise a question, burning question, you may raise your hand in the chat room, or you may also request for a question. You may raise your hand, or you can type in the chat room. We have one question from Firman Hadi. I would like to ask the potential use of AMD graphic card for machine learning. So if Dr. Girgin can answer the question from Firman Hadi.
Yes.
Please.
Well, unfortunately, for the time being, AMD is not a strong actor. So basically, NVIDIA is dominating the market, and basically almost all available frameworks are based on CUDA technology. And from that point of view, I don't see any chance in the near future for AMD to play a significant role in that aspect. It doesn't mean that you cannot use AMD cards. So basically, there is OpenCL libraries that are available, which allows the use of AMD cards for computation purposes. But unfortunately, the support is not much. So if you need to invest for GPUs, I don't suggest to use the AMD and go for NVIDIA.
Okay, thank you. I hope that answered the question raised from Pak Firman Hadi. Now, there's also another question raised by Pak Rizky Hanintyo. If Pak Rizky Hanintyo is available, you may unmute your mic and ask the question directly to Dr. Girgin, please. I would like to read the question posted by Pak Rizky Hanintyo. The question is, sustainability of the framework is important. Which one is better between Keras, PyTorch, or Tensor in the point of view of support and community? Dr. Girgin, please.
Yes. For this, my suggestion is Keras. And the reason why I suggest Keras is a high-level framework. So basically, Keras is in fact using a PyTorch and TensorFlow to do the computation. So that means it is compatible with the changes that will happen in the low-level frameworks. So if you learn how to use Keras, you don't need to learn the details of TensorFlow or PyTorch. So from that point of view, my suggestion is for let's say basic and medium machine learning purposes, go for Keras. if you want to, or if you need to do optimized machine learning, where you need to customize a lot of settings, options, then it is better to go for PyTorch or TensorFlow. And actually, one thing that I need to also highlight is basically TensorFlow and PyTorch, they are machine learning platforms, but they are not in fact specialized platforms. Basically, they allow you to also perform very low level computations, the matrix algebra level. So that means they can be also used for that purpose, which is not possible for Keras. So Keras is more high level machine learning purposes.
Okay, I hope that answered the question
Pak Irawan.
by Pak Rizky Hanantio. The next question will be raised by Pak Irawan.
Yeah. Thanks, moderator. Can you hear me?
Please loud.
Yeah. Okay. Thanks, Serkan, for the very great presentation. I would like to asking about there are a number of concerns surrounding the moral and ethical values with regard to the collection of high resolution geospatial data. Several studies have mentioned that how the anonymity of highly focused spatial data can be easily compromised by linking such data set to other databases. So do you have any thoughts on the ethical and moral values?
Okay, this is a very valid point. To be honest, so data privacy is a problem, especially for the data collected through mobile phones or platforms. And ethics also is becoming an important topic, also for artificial intelligence. So there is not an easy solution, to be honest. Because basically, if you really need to work with big data, having a in-house infrastructure which is safe from data privacy point of view is not very easy to have. So it's quite costly and it is difficult to maintain. So at one point you need to rely on existing services and infrastructure, which means the data needs to be stored remotely. My suggestion is to check the service providers who have certificates, because basically this need is not only our need. So basically there are also many governmental needs. So there are many governmental offices, services which needs to protect the data that they have. And for that purpose, the service providers, they provide some certificates that basically guarantees limited access to data, how the data is accessed, etc. So check what the service providers are promising from that point of view and choose accordingly. So that is my suggestion.
Okay, thanks, Serkan.
Okay. Is there any other question, burning question from other participants? You may unmute your mic and speak.
I think there is a question which says Microsoft Azure look like Pantano or Hadoop. Is it almost similarly or something? So maybe I can clarify. So basically, Microsoft Azure is a set of services provided by Microsoft, and like the services provided by all major cloud service providers, those services are based on existing technology. So they don't provide new technologies, but they provide existing ones, mainly the open source software solutions, as part of a service. So basically, the software that you can install by yourself is already installed and already optimized for their infrastructure. So from that point of view, they guarantee a good performance. So basically, Azure is not, it cannot be compared with Hadoop, because Azure in fact provides a Hadoop file system as a service. So it is a combination of these products.
I hope that answered the question from Muhammad Dayu. There's also a question about, will this recording be shared? This recording will be shared and available in YouTube right after, like a day after the presentation. Like we have a weekly presentation, and each week the recorded video is shared and available in YouTube. Is there any other question from our participants?
May I take the words for a moment?
Yes, please, Jorian.
Please. It's not a question on the content, but Serkan, thank you very much for sharing your presentation. I was very, very pleased to see that you put alumni in your first setup of the Geo Big Data Center, because I think the alumni are an important part of our community, and a lot of people talk about it, and a lot of people say always alumni are important and we should use them, but for once now in a working concept of a model, I see alumni really there, which makes me very happy. So I'd like to thank you for that, and I hope, as we're colleagues since 2-3 months, I hope to see you in person, hopefully in the fall or in the next academic year, and we will have some discussions on how to communicate this further to our alumni. So that's only what I wanted to say. I'm very glad that we're here again, and I also saw Pak Iwan, thank you for joining again. Good to see you after the tough time you had with your personal issues. And well, I hope to see everyone again the next time, because I really enjoy these sessions.
Thank you very much, Jorian, for the remark. We are proud to be ICT alumni for sure.
I have also a comment on that. So basically, I think you are very important, because this knowledge transfer is 2 ways. So that's clear. So the technology is evolving fast, and you are all actors in the field who are using these technologies in your daily life. And basically that is a very valuable experience. And I believe that should be shared among us, because the idea is to have a lifelong learning and sharing of the information. So from that point of view, I believe we can provide you some information with the developments. For example, the newsletter, I think it's a very nice way. So I highly suggest you to subscribe for the newsletter, so that we can send you monthly news about the developments in the field. And please also follow our Twitter account, because with the Twitter we can also provide a more frequent updates also about the meetings, about new data sets, about the developments. So in that way we can be in contact. And whenever actually you have some applications in your domain which involves big data, we will be very happy to hear about it. And we can also share this through these channels with a wider audience. So I think it will be very nice from that point of view. And I consider actually all of us as a family. So we are together here to learn more and to benefit actually from the technology. So that should be the idea. Thank you very much for giving this opportunity. So it's really an honor for me. I hope maybe in the future also we can, well, for the time being I am the only member of the center, but we will have more members. So probably they will also have additional experience which they can share with you. And our staff and students, they're also doing a lot of studies involving big data, sometimes directly, sometimes indirectly. So probably we may also have some presentations about it to show the case studies. So hopefully we will be in contact. Thank you.
Thank you.
Can I have a small comment on that?
Please.
Yeah, Yorin and Serkan, thank you very much for your very first comment. I just have an idea. Is it possible to have a refresher course online? I mean, we have a lot of refresher course, but it's not online. Now we have this technology. Maybe if there is an online refresher course for ITC alumni, a series refresher course, that would be nice. Then we can refresh our knowledge about remote sensing and GIS. How about that, Jory?
Yes, I think looking now at all the possibilities and all the technologies we're using now as a university, we have been online for 14 weeks, if I'm correctly now, and all the teachers are giving their classes online. So I think for the future there will be opportunities to involve this further and to see what the possibilities are, because I think it's important to be in touch. It's an easy way to be in touch. Officially, I'm doing something now what's not allowed, because for the university we are not allowed to use Zoom. Though I don't mind breaking some rules to talk to my alumni, so I'm just using Zoom on my university computer. But I really do think this is a possibility, because it saves a lot of funding, it saves a lot of time, travel. Though on the same side, I think the best thing of the refresher course is also the personal contact to have face-to-face with the teacher, with your fellow alumni from different parts of the country, which gives different contexts as well. So I don't think we can skip the refresher courses face-to-face, but we can add the digital ones towards the normal physical ones. We will see, we will have to develop, and topic-wise, it should come from the alumni. Of course, your topic is not my topic. I'm a communication specialist, and I'm completely different. So I'm always willing to, well, as I do, moderate, look to people into ITC, find professors, find teachers, find interesting speakers for you guys. But if you want to be active that way, please let me know which kind of topics you're looking for, which kind of projects, which kind of joint education, because then we can set up something like this NEDtalk and start working it for next year. Maybe something nice for next year, because of this year ITC exists 70 years in December, but due to the corona, the directorate decided to postpone the 70-year celebration to next year. So maybe it would be interesting to develop a series of lectures in the ITC 70 years year to celebrate the existence of ITC and to refresh knowledge from everyone, and not only from Indonesia, but maybe make it more broader in other continents, though time difference will be quite a hassle, but that might make it interesting as well. So yes, I'm very much interested, and I think we should develop something in fall to see what we can do.
Thank you.
Thank you, Julian. I think it's very good to explore opportunities and also discuss about possible future collaboration. This is among the aim of this weekly meeting that we are holding today. So, yeah, I think we can also continue to the next participant who are asking question. Pak Rizky Hanintyo posed another question. Oh, no, sorry. Dadan Ramdhani, the question is, which one is better between Azure and Google Cloud Platform in machine learning? Dr. Girgin?
It's the one that I answered, actually. I already answered that question. Oh, sorry. Okay, that's a new one. Well, I think it is difficult to say which one is better, because I believe there is no such situation with respect to provided infrastructure and basically the services, because they are all good in the physical infrastructure. And as I mentioned, basically most of the tools that are provided, they are already available open source products, so they are quite identical. What I can tell you is for Google Cloud, it is possible to use these specialized processing units which are developed by Google. So basically, if you want to experiment with this, then it is a good option. And actually, basically, that is the only option available. From Microsoft point of view, Microsoft provides easy to use interfaces. So like this block programming. So instead of writing the codes, you can use the interface, you can create the boxes and connect them to create your workflow. So from that point of view, Azure can be interesting to use. So there is not much difference, I can tell you. But don't expect the things go very smoothly. So I should also warn you about this, because using a cloud infrastructure, it needs some learning time. So basically, you need to learn the interface, you need to learn the logic, how it works. So basically, okay, once you open your account, you will access a page where there is hundreds of services listed. And it is difficult to understand which one works in which way, which are for paid, for which you need to pay how much. So this is a little bit complicated. But don't be afraid. So all these service providers, they provide limited duration or limited amount of cloud credits for free. So in case of Google, for example, there is a $200 credits for free initially. So you can create an account, you can test the available tools, technologies to understand how they work, and there is no risk in it. And it is the same with Google, it is the same with Azure, it's the same with Amazon Web Services. So don't be afraid to experiment. But also my suggestion is not to try many because basically it takes a lot of time. So if you are a Google user, so let me formulate in this way. So if you are already using Gmail, so if you are an Android user, then using Google could be better because it is better integrated. If you are already a Outlook user, if you use Office 365 for your daily usage, then going for Microsoft Azure could be a better option.
Okay. Thank you for your answer, Dr. Girgin. I would like to highlight about the YouTube channel where normally we record and publish our weekly webinar series. Pak Hartanto Sanjaya already posted the link, the NEDtalk channel, so you'll be able to access that and replay or visit our previous recorded videos from our previous 5 webinar series. I would like to say that we have a very fruitful discussion. We have a great presenter who already thoroughly present a very interesting topic pertinent to big data analysis, which is a very booming thing right now, evolving technology right now. But time is our constraint. So before I close our weekly webinar series today, I would like to say thank you again, Dr. Girgin, for your thorough presentation. We are honored to have you here. And I would like to also give thanks to our guests, Pak Tom Lauren and Yurian Terlu, for your active participation in our weekly webinar series. We really appreciate that. I would also like to thank our working team, Pak Hartanto Sanjaya, Pak Lena, Pak Irawan, Mas Syarif, Mas Iwan, Mas Emba Tampang Alo, and all people in our ITC-RC WhatsApp group. I would also like to thank the participants today. Thank you very much for your time. We hope to see you again next week. I would like to introduce next week's presentation. Next week's presentation will be my turn.
Oh, that's great.
So I would like to introduce myself at the end of this presentation for the next presentation. So the next presentation in our NEDtalk webinar series will be pertinent to COVID-19 pandemic, using GIS spatial analysis to study the spatial pattern of COVID-19 spread in Manado, West Java, Indonesia. So hopefully we will have you back here next week. We are really looking forward to have you back next week. That's all for me.
Maybe one thing.
Okay, sure.
Just a short question. Every week I try to share photos of this event on social media, and I try to tag as many people as possible. But I can't find everyone always, all the time. So please look for me, my name or the ITC alumni name on Instagram, on Twitter, on Facebook, and add yourself, because then it's easier for me to tag everyone who is involved. And if you see you're not tagged, please let me know and I'll tag you anyhow. This is how we communicate to everyone and share our great stories. Thank you.
Thank you, Yurian, for the remark. Okay, good afternoon, everybody. Thank you very much for participating this week. We are looking forward to having you back next week and our NEDtalk series next week. See you.
Thank you, Serkan.
Thank you.
Yurian,
Bye-bye.
thank you.
Bye-bye.
Thank you.
Bye-bye.
Bye.
Bye.
Yeah. Take a picture.
Terima kasih, Mbak Ilham. Oh ya,
Please,
take a picture.
Terima kasih Bapak Ibu yang
Sudah dari tadi.
Kami tunggu kembali kehadirannya minggu depan.
Bu Dia, terima kasih banyak sudah hadir, Bu Dia.
Oh ya, Bu Dia, terima kasih.
Ya, terima kasih
waktunya.
Ibu Lasmini, terima kasih. Sama-sama.
Sehat, Bu? Apa kabar, Bu? Udah keluar.
Oke, terima kasih semua ya. Sampai jumpa minggu depan. Oke.
Sampai minggu depan.
Channel yang sama. Di Zoom yang sama.
Di Zoom yang sama. Bu Lasmini, terima kasih.
Thank you.
Oke,
Thank you,
saya-
Sarkanto.
Yuk, sama-sama. Saya tutup ya ruangan ya.
Leave dulu, leave.
Terima kasih.
Oke, bye-bye.
Bye. Bye everyone.